Hello everyone, today we're going to look at the right triangle. So in this section we learn what is called solve right triangles. And this means that we are given three pieces of information of a triangle, the right angle, at least one side, and then the third piece. And we need to find the other three pieces. So remember there are three angles, three sides, so there are 6 pieces altogether. We're given 3 of them. And we need to find the other 3. So we always write our angles in the following way. Capital letters are the angles, lowercase letters are the sides. The 90-degree angle is C, and the other 2 angles are A and B. Doesn't matter which angle you call A, which one you call B, but I'm just going to keep it with the order that I have it right now. The sides that are opposite the angle of a certain letter is the same letter. So the hypotenuse is opposite the 90-degree angle, so it's the same letter. The angle that's, the side that's opposite angle B is lowercase b, and the side that's opposite angle A is lowercase a. It is very, very important that you label them correctly. So again, I can flip my angles A and B, but then my sides would also flip. Okay, so again, C is always the right angle and the hypotenuse. The other 2 doesn't matter, just make sure the side with the same letter is opposite that angle. To solve these triangles, we're going to use 3 things. The first of which is that the sum of the 3 angles in a triangle is always 180 degrees. Now we know we have a right angle, which means again C is 90 degrees, so the other 2 sides, A and B, must also be 90. So we're going to use that piece of information. We're also going to use the Pythagorean Theorem. So remember, a squared plus b squared is c squared. We're also going to use something that's called Sohcahtoa. Okay, so Sohcahtoa. This is going to tell us how to use the trig functions in connection with our right triangle. So if I have a right triangle, again, I'll have A, B, C, there's my right angle, C, A, B. So the Sohcahtoa stand for, we have sine, cosine, and tangent, that's the S, the C, the T, and the O, H, and A stand for opposite, adjacent, and hypotenuse. So we're going to do it in terms of A for now. Okay, so C is the hypotenuse. That's always true no matter what angle we're looking at, right? The side opposite the 90-degree angle is the hypotenuse. The side opposite the angle, again across the triangle with the same letter, is the opposite side. And then the other side, the side that is connected to A that's not the hypotenuse, is the adjacent side. So remember, adjacent means next to. So for every angle, and in particular we're going to do A and B, so C is not really going to have an opposite or adjacent. So for A and B, the side opposite it, across the triangle with the same letter, is the opposite side. The hypotenuse is the hypotenuse is the hypotenuse, again that doesn't change. And then adjacent means next to, so the side next to your angle that's not the hypotenuse is the adjacent side. So Sohcahtoa tells us that sine of our angle is the opposite side over the hypotenuse. So SOH, sine, is opposite over hypotenuse. Cosine, is adjacent over hypotenuse. So again, CAH, cosine, is adjacent over hypotenuse. And then tangent, I'm going to do it up the top because I ran out of room. Toa, tangent, is opposite over adjacent. So this is a quick way of remembering it without having to put our angles into standard position on the Cartesian plane. It's going to be the exact same thing. If you think about our triangle here, you can think of A as being in standard position, and this is a quadrant 1 triangle. So our adjacent would be our x's, our opposite would be our y, and then our hypotenuse would be the r, and if you notice, it's the same exact thing. Okay, but again, this way, I don't have to rearrange my triangle to put B into standard position. I know that if I want sine of B, it's going to be B's opposite, which is in this case lowercase b, over the hypotenuse. Cosine of angle B would be the adjacent, which in B's case is A, over the hypotenuse. Okay. And then tangent of B would be its opposite over its adjacent. Okay, so we're going to be using this throughout the section, so hopefully we'll get used to it. So we're going to do our first example. So here's a triangle. Again, C is the hypotenuse, and angle C is the right angle, it's the 90 degrees. And I'm given that angle B is 65 degrees, and side A is 23. So I'm given angle B, angle C, and side A. And I need to find the other three pieces, angle A, side B, and side C. It's always easiest to find whichever piece, angle, or side that I have two of. So in this case, I have two angles, and it's easiest if I find the third angle first. And I'm going to use the fact that A plus B equals 90. So if A plus 65 is 90, A must be 25 degrees. Don't forget the units. Okay, if it's an angle, you need to have the degree symbol, especially because later on we're going to talk about different types of angles. We're going to have degrees, we're going to have radians, so it's really, really important that you remember to put the units. So A is an angle, so it's 25 degrees. Next, we need to choose a side. Doesn't matter which one. I'm just going to go alphabetically, but you could do C first if you wanted to. So what we have to do here is we have to keep something in mind, which is that we don't want to use what we found. So the fact that I found A means I do not want to use it to find my B or my C. If I made a mistake in finding angle A, if I forgot to borrow a 1, and I put 35 instead, and I use that to find my side B, there's now an error in that. And if I used either of those to find my side C, there's now an error in that. So you never want to use what you had to find. I will take off points if you do it. Okay, so you have to make sure that you're only using the given information, which in this case is the fact that B is 65 degrees and A is 23. Okay. So like I said, I'm going to go alphabetically, so I'm going to look at B next. So first I'm going to erase the red that I just marked down. So I'm looking for side B. I know side A, and I know angle B. So according to angle B, I know the adjacent side, again, the side that's next to B that's not the hypotenuse, so the adjacent, and I know the opposite, the side that's across the triangle. So I go back to Sohcahtoa, and I look for which of those has opposite and adjacent, and that would be the toa. So this is telling me that I need to use tangent. So I set it up as the following. Tangent of B is little b over little a, so tangent of the angle B is side B over side A. Again, right from Sohcahtoa. I plug in what I know. I know angle B is 65, I know side A is 23, and then I solve it for B. It's a really nice one-step problem, just multiply both sides by 23. And the last thing I have to do is plug that into my calculator. Right, make sure your calculator is in degree mode. And you should be getting 49.32. I want to make sure that you're actually doing this out, so make sure you have a calculator with you. Make sure you're getting the same answers. So next we have to do side C. So again, we have angle B, we have side A. Side A is still the adjacent side for B. C is the hypotenuse. So I need to go back through Sohcahtoa and look for which part has adjacent and hypotenuse. And that is the ka in Sohcahtoa, which means I need cosine. So cosine of B is A over C. Again, I'll plug in what I know. Now I want to solve this for C. So don't forget, what you want is in the denominator, and there's two ways we can go about solving this. I can either think of this as a proportion problem, right? I can write cosine 65 as cosine 65 over 1, and I can cross multiply. Or I can multiply both sides by c and then divide by cosine of 65. So whether I'm just multiplying by c to get it out of the denominator or cross multiplication, either way, you're going to get that c is 23 divided by cosine of 65. So make sure you're solving these correctly. The biggest mistake I see on these things is that people will take this equation, divide both sides by 23, and call it a day. But remember, that makes my right-hand side 1 over c, not c. So I do have to bring the c out of the denominator in some way. So c is 23 divided by cosine of 65, which gives us 54.42. So I found all three pieces. What's left to do is check my answer. There are a couple of ways I can check it. The first way is to use the Pythagorean Theorem. Is a squared plus b squared c squared? So I do out a squared plus b squared, and then I do out c squared, and I notice that they are pretty similar. And remember, I did round in here, so they're not going to be exact. But a squared plus b squared is very, very similar to c squared. So I know I did it correctly. Another way to at least check that your answer is plausible is to remember that if angle A is smaller than angle B, then side A must be smaller than side B. And the reverse is also true. Also remember the hypotenuse must be the largest side. So our hypotenuse is C. That is the largest side, so that's good. And then angle B is bigger than angle A. Side B is bigger than side A. Okay? So you want to make sure that they're at least in the right proportions. Is the biggest one supposed to be the biggest one? Is the smallest one supposed to be the smallest one? Okay, but again, you can actually check it by doing that with the Pythagorean Theorem. So let's try another one. So here I know, again, angle C is my right angle. I know side C and I know side B. Again, the easiest thing to solve for is whichever one you already have two of. So in this case, it's easiest to find the third side. We're going to do that using Pythagorean Theorem. So a squared plus 32 squared equals 45 squared. Subtract your 32 squared, square root it, and you should be getting, again rounded, 31.64. Okay. So notice right off the bat, A is smaller than C, which we need. And in this case, B is again bigger than A, sidewise, which means at the end we got to make sure that our angle B is bigger than our angle A. So our next step is to find A and B. Just like with the sides in our previous example, it doesn't matter which one you do first, but again, I'm going to go alphabetically. So I'm going to start by looking for angle A. Now again, you can only use the things that you found, that you were given. Sorry, do not use the things that you were found. So I was given side B and side C. Side C, again, is the hypotenuse. Side B, in relation to angle A, is the adjacent. Again, it's next to it, and that's what adjacent means. So again, we go through Sohcahtoa, and we come up with AH comes from ka, so I want cosine. So cosine of A is 32 over 45, so I've plugged in my B and C, my adjacent over hypotenuse. Solving for A means I need to take cosine inverse of both sides. So A is cosine inverse of 32 over 45, which is 44.67 degrees. Make sure you know how to use your inverse functions with fractions, so make sure you put the parentheses where you need them. Okay, and again, make sure your calculator is in degree mode. Next, we're going to find B. again, we have the hypotenuse, but now side B is the opposite to angle B. So I've got hypotenuse and opposite. That is so from Sohcahtoa. So I know I'm going to be using sine. So sine of B is 32 over 45. Again, if I know sine of B, to find B, I take sine inverse. So B is sine inverse of 32 over 45. And I get 45.33 degrees. Okay, so again, I've got 3 answers. I need to check them. One way to check them is to use the fact that my 2 angles must add up to 90 degrees. Which they do. But notice that this doesn't tell me that I found the two angles correctly. I might have accidentally switched them. 44.67 could have been B, 45.33 could have been A, and just doing this out isn't going to prove that I did them the right way. Which is when I want to go back to the fact that side A was smaller than side B in this case. So I need to make sure that angle A is less than angle B, which it is. Okay, so I did do it correctly. I didn't accidentally switch them. So that's something you should always keep in mind. Okay, so let's try another one. So again, we have angle C, now we have angle A, and we also have side A. So again, the first thing we want to find is the thing that we have 2 of, which is angles. So we're going to find angle B first. So B plus 50 equals 90. So B must be 40 degrees. Again, remember it's an angle, so it's 40 degrees. Next, we're going to choose a side. Again, it doesn't matter. I'm going to go alphabetically. So I know side A, I know angle A, and I'm going to look for side B. Side A is opposite angle A, and side B is adjacent, because again, it's next to it. And that comes from TOA. So I'm going to be using tangent. So I'm going to plug in the numbers as well. Tangent of 50 equals opposite over adjacent, so 10 over B. Again, B is in the denominator, so just like with C in the previous example, I need to multiply B by both sides and then divide by tangent of 50. So B will be 10 over tangent of 50, which is 8.39. Next, I'm going to find C. So C is the hypotenuse, and again, side A is the opposite side. So which of Sohcahtoa have opposite and hypotenuse? That's so in Sohcahtoa, so I know that I'm going to be using sine. So sine of 50 is opposite, which is 10, over hypotenuse, which is C. And again, what I want's in the denominator, so I got to be careful when I solve for it. So C will be 10 divided by sine of 50. Plug that into the calculator. You get 13.05. To check it, I'm going to use the Pythagorean Theorem. And it does work out. But again, it's not telling me if I put the 2 sides in the right spots. So I need to check it. Is my hypotenuse the largest side? So I've got a legs of 10 and 8.39, hypotenuse of 13.05, so that is good. It's on the right spot. And then I look at my angles, and I notice that angle A is bigger than angle B. And is side A bigger than side B? 10 is bigger than 8.39, so I did do it correctly. Okay, so now we're going to do our last example. We have, again, angle C. We have side A, we have side B. So again, the first thing we're going to find is the third side, because that's the one that we have 2 of already. Pythagorean Theorem, C should be 5. This is what's called a 3-4-5 triangle. It's a very creative name, I know, but it comes up fairly often, which is why it has its special name. The next thing we're going to do is find an angle. Again, doesn't matter. I'm going to go alphabetically. So I know sides A and B, and I'm going to look in relation to angle A. Side A is opposite, side B is adjacent, and that means tangent. So we're going to look for tangent of A being opposite over adjacent. So tangent of A is 3 over 4, which means A is tan inverse of 3 over 4. And that should be giving you 36.87 degrees. Next, I move on to angle B. And again, I have the opposite and the adjacent. So that's still tangent, but now my opposite and adjacent have switched places. So tangent of B is 4 over 3, which means B is tan inverse of 4 over 3, which is 53.13 degrees. Okay. So again, I'll check it first by making sure my two angles add up to 90, which they do, and then I'll make sure that I didn't accidentally flip my A and B. So if I look at my sides, I see that B is bigger, and if I look at my angles, B is also bigger. So I did do it correctly. Okay, so again, it's really, really important that you, A, do not use pieces of information you had to find, and B, you check your answer. Okay, so make sure you read the book, try out some more problems, try the homework, and let me know if you have any questions. Thanks.